When we write a whole number in base 10 notation, there's exactly one way to do that. So if I write, for instance, the number 1, 2, 3, 4, this is the only way I can write it down. But fractions are completely different. If I think of the fraction 1/2, I could also write that as 2 over 4, 3 over 6, 4 over 8, 5 over 10, etc. There's infinitely many ways I can do this. In general, we can say that a over b is the same thing as a times 2 over b times 2, the same thing as a times 3 over b times 3, etc. So in this video, I want to talk about why every fraction is equivalent to infinitely many other fractions. Why is it that I can do this with fractions? Let's start by considering 3/4 as well as 3 times 2 over 4 times 2, which would be 6 over 8. Let's think about this as the lengths of rods, how we defined fractions. Here I have my rod and I want to form 3/4. So I'm going to start by dividing the rod into 4 equal pieces. 3/4 then consists of 3 of these individual pieces, and we'll pretend like these are equal. So this would be 3/4. I'm now going to take this exact same picture and I'm going to divide each of these segments in half since I multiplied by 2. So we'll split this one in half, this one in half, this one, and then the final one. And we can see now we have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And 1, 2, 3, 4, 5, 6 shaded. So this would be the 6 over 8 that we have up here. So now we have shown that 3 over 4 is the same thing as 3 times 2 over 4 times 2, which is 6 over 8. There wasn't anything special about the numbers 3, 4, and 2 that I did here. In general, this will work if a over b is our original fraction. We can multiply both the top and the bottom by any number. And then these will be equivalent using the same type of reasoning. If we understand multiplication of fractions, we could also show this as a over b is the same thing as a over b times 1, since multiplying by 1 doesn't change anything. Well, I could write this as a over b times n over n, since n over n is 1. And then multiplying fractions gives me this is a times n over b times n. So if we understand the idea of multiplying fractions, I can also show it this way. So this is a much more advanced version since it does rely on the more advanced notion of fraction multiplication, whereas my previous explanation with the diagrams relies only on the definition of a fraction.